Hey guys, today we're talking about solving a system of equations for its number of solutions. We've talked about one solutions, where the two lines intersect at a common point, and this point is a solution to both equations. But what we haven't gone in depth with is when there's no solution, when the lines are parallel, or when there's infinitely many solutions when the lines are the same line. So that would mean that the two equations are the exact same and they form the exact same line. All right, so what do the equations look like? Make sure that you have maybe a sketch at least of the three examples. Okay, so let's look at some examples in this case. Let's recall when we have one solution, you can use combinations, substitution, you could even graph them. Excuse me, and what these look like is when you have two equations, and they only give you one solution answer, okay? So, for example, here we used combinations or elimination to multiply this side by 4 and this side by a -3, and we got x equals -7 and y equaled a -9. If you want to pause the video and look at that one a little bit in depth just to recall one solution, that's fine. But what we haven't talked about is infinitely many solutions. So, for example, let's look at this step by step. So I'm going to just show you the two equations to start off with. Okay, so we've got two situations here. As far as I can see, it's easy for me to get rid of this 5x because I can multiply this side by 3. So if I distribute a 3 to both sides of this equation, I get negative 15x plus 21y equals 63. And if I look in depth here, this side cancels out, this one cancels out, and this one cancels out. So if these are 0 and these are 0, I'm adding 0 plus 0, and this side is 0, then 0 equals 0, which, as we know, that means that there are infinitely many solutions. It means that every single point will work. So if I plug in any number in for x and any number in for y, if I plug any number in for x into both of them, it's going to give me the same y. If I plug any number in for x again, a different one, it's still going to give me the same y in both equations, meaning that they are actually, if we look, infinitely many would be that they are the exact same line. Okay, so let's explore that a little bit more. If I actually look at these, and I instead multiply by a -3, that'll change this to a positive, this to a negative, and this to a negative, right? Because a negative times a negative is a positive times a positive is a negative, and a negative times a positive is a negative. So if you look in depth here, these are the exact same lines. So we don't even need to go as far as doing the 0, 0. We can see that if we multiply by a -3, that they become the exact same line. Okay, what about this one? I'm trying to get rid of one of my variables. So on this side, I can distribute a 3, which would give me a -x plus 3y equals 24. So if I do this, these cancel out, and this becomes 29. And 0 does not equal 29, therefore there are no solutions. Okay, let's explore this a little bit more in depth as well. If I make this a -3, then this is a positive x, this is a -3y, and this is a -24. Okay, if I look at this, and I know that if I move my x onto the other side, that this would be -3y equals a -x minus 24. Divide everything by a -3. Okay, so we get y equals, or positive 1/3 x plus 8. Okay? So really all I had to do was just add the 1/3 x to both sides. So y equals a 1/3 x plus 8. Okay? So on this side, excuse me, I'm going to take the x away from both sides, and I'm left with negative 3y equals a negative x plus 5. This is what I really wanted to do first, since that one would have been so easy. So divide by a negative 3 on both sides, and y equals a positive 1/3 x plus 5/3. If I look at the slope of each of these lines, it's the same. When we look at the parallel lines, their slopes are the thing that's the same. Their points of intersection are going to be different. So that's why they are parallel, because they're rising and running, rising and running, rising and running at the same rate, which means that they won't ever touch. Okay? So go ahead and try these. Pause the video, take a second, try each one. I'm going to be back in just a second to show you the answer. And we can talk about these more in class if you would like. So here we go. The first one is infinitely many solutions. Oh, I'm supposed to click. The second one is one solution. And the third one is no solution. Why, you ask? Well, if I multiply this one by 3, I get the exact same equation. So infinitely many solutions. Number 2 is just a normal equation. So I would multiply all of these by a negative 2 and get rid of my y. So negative 2x minus 2y equals negative 19. Okay, so when I get rid of this, x equals 0, so one solution. Down here, it's no solution because if I take y equals 9x plus 7, okay, so we're going to substitute this one into this equation, and we get negative 18x plus 2 times 9x plus 7 equals 8. So what we really have here is negative 18x plus 18x plus 7 equals 8. These cancel out, so 8 and 7 do not equal each other, so no solution. Okay? And that's all I've got for you today, so I'll see you next time.